Ember. There you go. That's good. Hi, everyone. Welcome to the Ember NYC meetup. My name's Hugh. We got a cool lineup tonight. We've got 3 lightning talks to start with, and then we've got Tom Dale, who's going to talk about the future of Ember in 2017. I was just going to start with a couple Ember-themed announcements. Ember 2.11 just came out, I think like a couple of days ago, and it builds on some of the awesome work that happened in Ember 10, which is the addition of Glimmer 2 as the next generation Ember.js rendering engine, which is really good. Everyone's kind of seeing a lot of performance gains and also like size of their apps decrease by significant amounts, which is really cool. And some of these changes also move Ember directly into an NPM module as Ember source, which is a pretty big deal. And also, if you haven't gotten EmberConf tickets yet, you should go and get them. Our whole team went last year, and it was really like a ton of fun, and I highly recommend it. And yeah, so the same with next month. We're going to be at Tumblr again. And Ollie from Tumblr is going to be talking a bit about Ember at Tumblr. Hey, Ollie. And then I'm just going to quickly open the floor to anyone who's got any announcements or kind of hiring stuff that they might want to mention before we get started. Anybody? Okay, cool. Well, I'll just say something real quick. I run a company called Sanctuary Computer. We're on ground in Bowery down in Chinatown. And we do a bunch of Ember and React development, so if anyone's interested in looking for a job, come let me know. But now I'm going to hand over to Ollie to talk about eating greens with broccoli.
Hello. Okay, cool. So let's get rid of this. Hopefully everybody has had time to see the Wi-Fi, and you've joined. If you've not, bad luck. Cool. So, who here has an idea of what Broccoli.js is? So that's about like half-ish of the room. So, Broccoli.js is the asset pipeline tool that's built into Ember CLI. When you go Ember serve, that's sitting on the shoulders of giants and loading Broccoli.js under the hood. So I have, over the past few weeks, been playing around with this, and I wrote a blog post on Broccoli.js titled "Eat Your Greens: A Beginner's Guide to Broccoli.js." So hopefully this will sort of demystify some of what's actually happening under the hood with Ember. If I've got any of this wrong, which I probably have, please, Ember folks, shout at me and let me know. So I'm going to skip through this fairly quickly because I've only got 10 minutes. So simple Broccoli setup. Make a directory. Those of you who want to follow along at home can do so. The URL is olliegriffiths.com. You can see it up there. You can feel free to follow along. So make a directory, go into the directory, install Broccoli. This will install the Broccoli CLI tool. I'll actually increase this so you can see a bit better. And initialize your directory with npm and add Broccoli as a dependency into your application. From then on, the main thing that you're going to be working with is this broc file. So I'm going to scroll on down and show you how this works. So we're going to try and live do this, and hopefully things will work. Cool. So I've already set this up with my node modules that I'm going to be using for this, and we've got a broc file here. So let's go ahead, and I'm not a Vim guy, so bear with me. This is our broc file. Nothing in it right now, so let's have a look and see what we're going to do. So first things first, we're going to make ourselves an app directory for where our application is going to live. So let's do that, mkdir-app. And in this directory, we're going to add ourselves an index.html file. So we're going to do echo hello world, and that's going to go into app index.html. Cool. So super simple, hello world. We're going to take the contents of this broc file, and we're going to drop it into the broc file here. So let's have a look and see what's going on here. So first things first, Broccoli is built on the basis of using plugins. Much like Gulp does and Webpack and so on, Broccoli works in a very similar manner that most of its functionality is made up with plugins. The big difference between Broccoli and like Gulp and Webpack and so on is that Broccoli works on the concept of trees. And you can think of a tree much like a directory structure. So when you CD into a directory on your laptop, you've got files, you've got folders. In those folders, you've got other files and other folders, and it makes a tree. And Broccoli works on this same basis. So when you're configuring your Broc file, you're working with these trees, and you can pass them around and do all sorts of cool things with them. You can combine them, you can merge them, you can concatenate all certain types of file in a tree into one file. You can do things like live reload, et cetera, but it all works on the basis of these trees. But the trees themselves are virtual in nature. They're not, when you're performing and setting up your Broc file, you're not actually doing anything on the trees themselves. You're merely declaring how these things are going to work when you ultimately build your application. So what are we doing here? There's this module or plugin called Broccoli Funnel. And basically, it takes an input. So we've got our app root here, which is our app directory. And we're saying, OK, find the files that are in this directory named index.html. You can also use like glob patterns to search for only JavaScript files. You can do pretty much any sort of file type operation for finding files, as you would expect. And you give it an output directory. The destdir here is slash. So we're going to put it into the root of our destination directory. And when we build this, we'll give Broccoli a target, and we'll say, you're going to build using this configuration, and you're going to put all the files in a target folder. So slash is the root of that target folder. So if we go ahead and run this now and do Broccoli build dist, we'll have a dist directory, and everything looks good there. And we can see in our dist directory here, we have an index.html file with hello world in it. This is exactly what we're after. So that's all well and good, but I'm a developer, and I want to have these things. I want to serve it. I want to be able to look at this and actually render this application in a browser. So there's a facility for that. We can do Broccoli serve. And it doesn't work.
Port number.
I have to give a port number? Oh, I've already got it running. Where are we? I was doing work. There we go. OK, Broccoli serve. We're good. So you should all be familiar with this. Localhost port 4200. And if we open that, we get our hello world page. So all looking good so far. So let's move on. Simple, we've copied one file into the target. It's going to move on, and we are going to skip past all of this, blah, 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 blah. And the next one we're going to do is Broccoli merge trees. So what merge trees does is it takes two separate trees and it merges them together. Think like doing an rsync operation on your laptop, and you say rsync this folder into this folder, and it'll copy all the files from one into the other. And you can do the same thing with trees. So we're going to do this here now. So we're going to make a styles directory, and we're going to put some CSS in our app styles app.css. We're going to add some JavaScript to an app.js, and we're going to make a document in our index.html. So let's quit out of that for now and run that. And we should now find that in our app directory, we have a styles and we have an app.js. In our styles, we have our background pale green, and we have our alert eat your greens. So if we Broccoli serve this, we should be back up and running. And if we're lucky, we have a nothing there. Oh, why is that? What happened? Let's check our index.html. That works. Let's get rid of that. App.js, app.css. Let's run it again. OK, good, good. No, it's not even copied the index.html. Oh, I didn't update the Broc file. That'll be why. So yeah, so this is still just copying our index.html, and that's not going to work. So we want to take our new Broc file, and I shall explain what's happening here. So now, this is good. Now we are going to be using a couple of funnels to copy various things from our app directory into our resulting output directory. So we're copying the index.html, we're just copying the app.js, and we're copying the app CSS in as well. So if we run this now, hopefully, oh, wrong one. Eat your greens, and it's green. Haha, okay, good, this works. Right, so yeah, good step. Step one, we've got an app. Ship it. Right, so next thing we're going to move on is to SCSS processing. So if you use a CSS preprocessor, which I assume most of you do, then you're going to want to be able to play around with that. So what we're going to be doing here is we're not going to do an npm install. We're going to just move our CSS file to our SCSS file. And you can see that, oh, good, body color. Cool, okay. So we defined a variable, body color, and we're setting the HTML background color to that body color, and we're giving it a border. So all things being well, when we run this, we should find an error because I've not copied my Broc file again. So let's do that. And what we're doing here now is instead of just copying a CSS file, we're going to run it through a preprocessor. So there is a module or a plugin for Broccoli called Broccoli SAS source maps, which does a couple of things. The main thing it does is it compiles your SCSS to CSS, and it also has the option to enable source maps. So I'm actually going to go ahead and copy that bit as well, because we're going to want that. So those of you who don't know what source maps are, it allows you to, when you inspect an element in your browser, and it says this was declared on line 5 of app.css, what it'll do with a source map is it'll say app.scss, and it'll give you the correct line number pre-compilation. So it's much easier to debug where styles have come from. Otherwise, you just get the CSS compiled output, and that's really not that helpful for you. So let's go ahead and serve that. Unexpected token. Ooh. Is it that? Nope. File not found. App.scss. App root. Ah, yes, that's why. Styles. Okay, cool. So if we refresh now, we should hopefully find we have a hello world. And yes, all looking good. We've now got our green border, and the background is still green. We've obviously compiled our SCSS there. And if we inspect this, we'll see that the source map is working nicely. I can see here, and you can see app SCSS line 2. And when you click that, you see the resulting SCSS file. Someone give me a shout for time when I've got like 1 minute, if you can. Cool. So next thing we want to do is CSS is cool and everything, but you know what? It's 2017 now, so we want to be able to do ES6 at the very least transpilation. And what that will do is allow us to write in our fancy new JavaScript language and have it port back to the old way so that it works in browsers, and everything will be good because browsers don't currently support ES6 entirely. So for that, we would install the Broccoli Babel transpiler. And what we're going to do is we're going to, in our app.js, going to put in some nice fancy new JavaScript syntax. So here we've got a constant defined, and we've got a function called foo. Within that, we've got a set timeout, just for demo purposes. And within that, we've got an arrow function operator with an alert and a console log. One of the properties of a arrow function is that it will inherit the context of the parent scope where it was declared. So this works automatically. You don't have to do any kind of function.bind or anything like that to redeclare what this is in that context. It automatically uses the parent context. So this should, when it logs out, should be the foo constructor. So let's go back to our Broc file and let's add, you know what, we'll just copy this. So what we're doing here is instead of our existing funnel, which we had to copy our JavaScript tree, we're taking that funnel and we're running it through Babel. And Babel will do this transpilation, copy it from the original format into a new format that the browser understands. So if we quit and rerun that, we get an error because Babel is undefined because I didn't copy it in. That's what we want. Oops. Okay, cool. So now when we run this, it builds, good. And if we refresh, cool, eat your greens. And we see we've got foo logged out here. So this is good. Everything is working nicely. We can see that app.js is where it executed this. And you can even see that the source map and everything is maintained for this ES6 syntax. So this is cool. We can now write our application in a funky new language with all the extra bells and whistles that ES6 gives us. But let's not stop there. So let's take this a bit further, and you know what? Let's actually have a look and see what the compiled output looks like. So let's build this. Broccoli build dist. So you can see what an ES6 to ES5 output looks like. We have this. So previously we had const for our message. Now we have var. Our function, still we have function foo. That's totally backwards compatible. Our arrow function here, though, we can see that this has been converted to a regular function. However, you'll notice that this has been declared in the parent scope, such that when you refer to it in the set timeout function scope, it still refers to the correct this. And everything then should work as you would expect it. So, going on forwards, this is cool and everything. So let's do like an ES6 import. So let's touch app foo.js. And let's import that from our app.js here. Cool, so we've got Babel running, it's converting everything. We're importing that, and from foo, let's put something in here. Let's export a constant, and let's export a default. So when we, oops, go away. When we import that, we should get the default import being the string foo, and an optional constant import of bar. So everything should theoretically be groovy, and let's say instead of console logging this, we're going to console log foo. So let's see how that works. So we're going to serve that. Everything's duplicate decoration foo. Oh yeah. Hello. Let's just change that function. So cool. Everything should be groovy. Let's go and run this in our browser, and this didn't work. Why didn't this work? Well, modules don't get converted through Babel in a way that you might expect, that they would just work out of the box. Browsers don't have any mechanism for loading modules asynchronously or synchronously, for that matter, in a require.js way. So in Node, you're going to do like var foo equals require, I don't know, jQuery, and that'll load the jQuery library from npm. Browsers don't have that require function, so it doesn't work, hence why require is not defined. So we can fix this. Let's go down and I'll show you how we do that. So there is a module bundler called rollup, and this does a few cool things, one of which is substitute those require functions with a bit of magic so that it works in the browser, and I'll show you how that works. So we can include the Broccoli rollup plugin, and we can go from there. So let's take that rollup plugin, and let's put it in the Broc file. And let's go down, and I'll show you what we do here. I'm going to just go copy this lot all the way down to here. So what rollup is going to do is it's going to allow us to have those require statements work within the browser. That's one of the things it's going to do. So what we've done here is we've replaced our our funnel with rollup itself, because it has the ability to do some of the features that funnel does already. And you can declare your input files, and you're saying, okay, find every JavaScript file in the application. And then what we're going to do is declare what the entry file is, so what the very first file that's going to be loaded is, and what the destination is, where we're going to write the output to. And we're also saying include source maps inline. So let's go ahead and run this now. So that's running. And eat your greens. Fantastic. Foo. This is working. Huzzah! So that's cool and everything, but what does that actually look like? Like, what is it actually doing? So I don't know why you have to. Anybody from Broccoli land knows why you have to remove the dist directory. I don't know. But anyway, so we're building out there. Let's go and have a look and see what this has actually done. So if we look at our app.js, we can see, okay, cool. So we have a variable called foo. Well, we had an import called foo, and we had an import, and we assigned it to something called foo, and then we console logged that out. So Babel and Rollup have together worked that out to say that's going to be a variable called foo, so that we can still console log it, and you can see that the import has been dynamically converted in line to what we have here. The rest of this is the syntax that we had before, and we're console.logging that out. So that works. And it works on the basis that we're no longer including things within self-executing functions, a la Webpack and some of the other like Browserify and so on do. This actually produces a much more efficient output for the browser to load and run and render and so on. But it has some other cool advantages. You may have heard of this term called tree shaking. And that actually kind of comes from the sort of Broccoli ecosystem. But basically what it does is it can work out what stuff we're not actually using here. So if you remember back when we looked at our foo.js, we're also including exporting a thing called bar. So, okay, let's import that. Let's import bar from here. But you know what? Let's not use it. Let's go ahead and build again and have a look at this output. Wait, what? Where's bar? That's weird. I included it, but it's not there. Well, I'm not using it. So it can actually work out through static analysis that I don't need it, so we can get rid of that code. And this is one of the things that we're hoping to bring to Ember in the coming X amount of time. I'll defer to the awesome RFC that Tom wrote on this, for any of you that are interested. We should be able to do this in Ember. So we can work out, you know what, if you're not using computer properties, don't import them. We don't even need that. Just get rid of that shit. We don't need it. It's not adding extra bits to our download. We can hopefully massively reduce the payload size of your Ember application. I'm going to leave this here now, because I've been rambling on for at least 15 minutes. There's more in the tutorial if you want to have a read through it. And that's Broccoli, basically. And if any of you enjoyed that, I'm going to tweet a link to a thing, and hopefully you can say nice things about me. And my Twitter is twitter.com/Ollie Griffiths. And
if anyone has a quick question for Ollie,
form.
we can probably do one. Anybody?
Yeah. I appreciate that was a lot.
Just means your talk was very good.
Excellent. Well, yeah, hopefully say nice things. You can follow this link here. Give me a rating if you think it was good. If you think it was terrible, you can also give me a rating, but there's free beer and pizza over here. So, yeah, thanks very much, and enjoy your broccoliing.
Awesome. Okay, so next up we've got Daniel Hunninghake, who's going to be talking about this library of his called Vudu. He's actually releasing it tonight, so we're all really excited about it. Yeah, so give us a sec while we set up the AV. Ember, Ember. Okay, so take it away, Daniel.
Hey, everybody. My name is Daniel Hunninghaki. I'm a developer at Kickstarter, but I had the privilege of spending this past year working with Hugh and company at Sanctuary Computer. Like, mad love for these people. And they are actually a big part of what I'm about to show you today. I worked on it on and off for the last half of the year, trying to build a solution that was going to work across a lot of our projects. We did a lot of React and Ember. And so the goal of this is to try and have it be reusable in general. So what is Vudu? It is a composable approach to writing styles in JavaScript. And whenever I tell people this, I usually get like a head tilt. There's some pretty strong opinions about styling and JavaScript in general out there. And actually some of you might be mad at me, but I beg you to be open-minded to what I'm about to show you today, because I think that it's been a really nice solution, not only in my own sort of side projects as a test case, but I think Hugh is also using it in a couple production builds. So it's definitely early stages and can use a lot of eyes on it, and feedback is like greatly appreciated. Okay, so when I tell people this, they normally think what I've been working on is inline styles. And my answer is kind of. Like, it draws on the patterns of inline styles, but when you declare styles with JavaScript and use them in React traditionally, you have to use it with the style tag, and it just spits out like a string, and it's really ugly. And but it's useful if you're trying to do really simple things. But with Vudu, what it does is it takes that object and passes it through a function, and does a decent amount of formatting and preparing, and then spits back to you an object that contains those styles. So you can do that with multiple. So container is one. You could do it. You could add a wrapper, button. You can add on different things, and it's going to spit back at you simple string representations of those styles. So then in your template, instead of doing style equals something, you're doing class, because what it's returning to you is a class that represents the sort of like grouping. And so then you can use in your template class equals whatever. And to sort of like explain why it looks like that, the V is there because it's a preventative measure in case someone tries to name their class by starting with a number, which happens. And so that sort of makes sure that it starts with a letter. And then the last part of it is a sort of unique identifier, because theoretically you could name multiple things containers in different components, and they're doing different things. So that's supposed to be a sort of stamp on that. Okay, so it looks nicer, but why do it? And the reason why is because there are some more complex things that happen in CSS that pure inline styles can't handle, like hovers, media queries, keyframes, these things that are a little bit more complex. And so I'm showing you this just as a sort of intro to how you might use some of these things. And forgive me if you all, what I'm showing you now is very similar to some other tools out there, but I'll explain a little bit later how it's sort of different and unique. But this is how you might use a hover in this container object. Similarly, like media queries are pretty easy. And in this case, it would start out red on like mobile, and then at, I guess, roughly iPad, it would switch to purple. Okay, so then you can also do nesting. So say you wanted to target an H1 within your container, you can get that, set a font size, and then also use those pseudo selectors and media queries and stuff within it. Okay, so what are some of the benefits of writing it this way? Well, One of them is that it's a single language, meaning JavaScript. If you can sort of offload some of the tasks from CSS, and even if you're using JSX, you wouldn't have to write as much HTML, then what results is the ability to test it better, to have a better type system, and also to have a linter that can cover more ground. And then also, you can include it directly in your components, so encapsulation. And another sort of word that goes along with that is collocation, which is like right next to it. So you can stay within the same file and deduce how something is being styled. And then there's also an awareness of state, because you can use the objects and classes that you set up to respond to the different state changes that happen within an app. This is actually one of the biggest reasons why I'm a fan of this. But then the last one is composability, and I'll get to this towards the end, but I think this is the real driver of this particular tool in comparison with other tools, is that it gives you the ability to set up objects and then reuse them all over the place, and then have your logical overrides and whatnot. Okay, so the fun part, how can I use this with Ember? There's a little bit of a caveat in that I haven't worked on or written an Ember add-on, and so you can npm Vudu and save it, and then also do like a save /d is like save dev of Ember browserify, which will allow you to use it similarly to how you would do an import. So in this case, the second line there, you would just do import Vudu from npm : and then it works like how you would traditionally use import. Okay, so this is like an example component, and you've set up your styles with Vudu, and that spits back an object of 3 classes, which are wrapper, active, and inactive. And then if you set styles as the very first thing, that's going to make it readily available in your template. So you can do something like this, where class equals styles.wrapper. And this, again, sort of what it was looking like. And then you can take that a step further and use class names within your component and set the wrapper on it directly. So then what that results in is actually something like this, where the paragraph tag is all you would need in your template, and it's just magically wrapped in this wrapper class. And then to take it even a step further, there's class name bindings, where you can start to actually get into the interactive stuff, like determining whether something's active or not. You can set up all your styles in this object prior to it, and then have them respond to the sort of state changes within your component. And so then what that looks like in the template is now you have both the wrapper, which is the class names, and active, which is the class name binding, which could potentially change to inactive. Okay, so now I think this is probably the coolest part of this, which is that you can use this in computed properties as well. And so what you're doing here is you're accepting a variable amount of things and then using Vudu to generate styles that represents that data that you're getting back. So in this case, there's an array. It could have a certain amount of things. And what this does is it takes all the items, depending on the number of things, and gives them a width. So if you have 10, it's going to give each of them 10%. 5, it's going to give 50%, or 20%. And so in this case, what you can do is actually have styles that are responding to the data that's coming into your components. And traditionally, how this would have been done is you would have had to set up your styles prior to that. So if you needed, for example, maybe 10, you'd have to set up your styles to, you'd have to statically do it first and then account for the cases that you might have, as opposed to only generating the ones you need when you need them, because all of this happens at runtime. And so then in the template, that kind of looks like this, where you have a basic each, and then what the class is doing is it's giving a float and a sort of custom width, depending on how many items are coming into your component. And this is sort of like, if I had to boil down the reason why I worked on this, it's that data is dynamic, and I think styles should be too. Okay, so then what about in routes? This is a little bit of a sort of strange case, because from my understanding, Ember's trying to steer away from controllers, But for now, the way we've been doing it is to use the setup controller to just set a styles property and use it that way. Okay, so a lot of people are using similar things like Aphrodite or Radium, and the problem that we came up against was that they supported most of what we needed, but not everything, and our requests for certain features were either denied or ignored. And so we just decided to build our own solution. And the main reason why I would consider it to be different is because of the composability that I was talking about earlier. So just to like illustrate that really quickly, you have a plain old object called object1, and then another plain old object, object2, and then what you can do is use this composes key at composes it's sort of like an object assign, but it's like a smart object assign. It like handles all of the nesting and all of the special cases that you have in these two objects that you're trying to mash together. And then you can also override whatever you're composing. So you could imagine this with like a button, for example. You'd have in your composes like button base, and then button big, and then button blue or something. And then you needed to override that. You could then have a property at the very end that's like color equals purple or something. And so then you're composing the majority of your element and then having one single override. And it also plays nice with React and Angular and a vanilla JavaScript project. And that's it. Also, let me qualify the sample. I put it up literally like an hour ago, so hopefully it works. And if not, then feel free to yell at me on Twitter or whatever.
Has anyone got a question for Daniel? Oh, Ollie, you want to go first?
So we've been using Ember Component CSS in our application. I don't know if you've come across it. Ember Component CSS, which is freaking awesome, by the way. You should all check it out. Essentially, it does a very similar thing to this. So we use the pod structure in Ember. So we have our component JS and our template HBS next to one another. And what Ember Component CSS does is it allows you to put a styles.css or SCSS or less file or whatever in that same directory and put your styles in there. But then it takes it a step further and it prefixes the component with an auto-generated class name like you have there, like with a hash in it. And then any styles that you put in your styles.sass or less or whatever get prefixed with that component name. So it also generates a component name, a class name when it renders the component, and that ties in with the CSS that you've written. So it allows you to kind of have this sort of best of both worlds. But I really like what you had there with the like dynamic, divide by X to determine the width of some number of things. That's really super cool. But yeah, that's just another way of doing it. I don't know which approach is going to win ultimately, but this is freaking awesome. Well done. And if you want any help with making an add-on, give us a shout.
I would love it. Yeah, I'm very open to any help and any feedback. I forgot that I have a really basic. This is what you would get if you pulled down Vudu Ember on my repo. But basically, it gets anywhere between 3 and 10 items, like randomly, and sort of like has a width based off of that. So that was what I showed in that thing. But yeah, to your point, I think it sort of depends on where you're coming from, because some people are more comfortable writing their CSS in Sass files and stuff like that. And if at the end of the day it's all compiling and working to the same place, then it comes down to preference. And I think we've just sort of landed on this pattern, going back to this idea of having one sort of unifying language. I think feels nice to me, but that doesn't necessarily mean it's the best.
We'll do one more.
Hey, so I saw the function generated a set of class names, and you put that on your element. How do styles actually get applied to that element? Do you like inject a sheet or whatever?
I meant to explain this, but I thought it might be too complex for a single slide. But yeah, what happens is that it goes in, gets formatted to CSS rules from the object, and then is attached to the CSS style sheet via the browser API. And then, then that updates the style sheet, which updates the DOM.
Cool. Thank you, Daniel. So next up we have Dustin Ferris, who's going to be talking about using Redux with Ember. So I'm very excited about that. Do you want to hear Mike or?
If anybody needs the bathroom or anything, there's one behind the screen, and there's other male and female ones downstairs.
Check, check. Can you hear me? Yes. All right.
Do you have slides or are you?
Yeah.
Okay, so you're up on the screen now.
Is this thing on? All right. Ready.
Okay, Dustin Ferris, everyone.
All right, thanks. Thank you. Thanks, Daniel. Vudu looks awesome. Inject rule, I think, is a big win for something like that. I can't wait to hear Tom talk, so I'll try to keep this short. My name's Dustin Ferris. I'm the co-founder of Industry Maps. I've been using Ember for about 2 years, and before that, I was a Django developer full-time, front-end and back-end. And I want to talk to you today about using Redux in Ember. Ember Redux is an add-on that was created by Torrin Billups to bring Redux into Ember and also to create an API to connect Redux to your Ember components. This is similar to another package called React Redux, which does the same thing for React components, but I won't be talking about that. So again, Torrin built this. Torrin and I and several others have been working on it for a while, trying to make it better. So what is Redux? Does anyone here know what Redux is? All right, a lot of people. Anyone using Redux or trying it out, experimenting with it in your projects? A couple of people? All right. For those of you who don't know, Redux is your application state. It's a package that keeps your application state in a plain old JavaScript object. So it's just an object that Redux keeps track of. It can be as simple or it can be as complex as you want it to be. And you access it with this getState function that Redux gives you at any time. You can get a look at this JavaScript object and see what it looks like. And then you can dispatch, with this dispatch function that Redux gives you, actions which will transform the state into something new using a reducer function that you implement. So Redux is data down, actions up. And it's just a plain old JavaScript object. Ember Redux takes Redux and connects it to your components. So what's a connected component? This allows you to take that Redux state from that JavaScript object and map it to computed properties on your Ember component. So imagine that you have a function here, state to computed. State to computed receives the current Redux state and then picks off a little piece of it for whatever you need for this particular Ember component that you're working with, and then connects it to your Ember component. So for instance, in this example, we're getting our state from Redux, and we're taking the current username off of that object, And we're going to return an object that's a map. And the name key here is going to become a computed property on your Ember component. And then you can use it the same way you would use, a computed property anywhere else, for instance, in your handlebars template. And the other half of a connected component is dispatching your actions. And that's done, again, by creating a function that receives the dispatch function from Redux, and then you can define your action handlers for your component using that dispatch function, so you can dispatch an action type to Redux and transform your state. So say, for example, your state is 1 mango. This is your application state, okay? And you want to create a button that when you click it, it's going to collect another mango. All right, I would write a function. I've got a component for a button, and I want to write a function that's going to provide that action, collect mango, but it's going to use Redux dispatch to dispatch something to my Redux store. So here's a function that takes the dispatch function from Redux and returns an object whose key is a function, collect mango, that's going to become an action on the connected component. And the implementation of collect mango invokes dispatch and sends an action type, collect mango, and that's received by Redux and run using a reducer that you implement. And for instance, in this case, it'll transform the state, it'll return a new state, and presumably in this case, that would be 2 mangoes. So again, data down, actions up. When we click something, we send an action to Redux, and it transforms the state. Now, I was going to live code extensively, but rather than shoot myself in the foot, and to save time, this does work. Okay, so my screen size got a lot bigger when I plugged in. Hold on. Is that readable? So I've got this application collecting mangoes. And this application is going to have a row of mangoes that I've collected on the top, and it's going to have a moving mango on the bottom that I'm going to click on, and if I catch it, I'm going to get a new mango. That's how I win this application. And in my application handlebars, you can see this is really simple. It's just 2 components. I've got a row on the top, collected mangoes I've collected, and I've got, on the bottom, I'm going to have this moving mango component, mango catcher, that I'm going to implement. Now, I've got this reducer. I didn't get a chance to talk about it much, and I won't, but the reducer will accept actions, and it will transform my state, my plain old JavaScript object state, depending on the action type it receives. So I define this initial state where I've got 0 mangoes and my initial position of the mango I'm trying to catch, which is at 100. And I'm going to receive 2 different action types, collect mango or move mango. If I receive collect mango, I'm going to transform the state. I'm going to take the, whoop. If I receive a collect mango action type, I'm going to take my state, I'm going to transform it by bumping the num collected mangoes by 1. And if I receive the move mango action type, I'm going to take my state, and I'm going to transform it by reassigning mango position x to some random number between 0 and 600. It's kind of blurry, but I think you can see that. So that's my reducer. Reducer takes these action types, returns a state. And in my component here, which is almost built, so this Ember component, got my layout, right in line there with my handlebars. It's showing my mangoes. For every mango that I've got, it's going to display a picture of a mango. The only thing that's missing here is a state to computed function that's going to take my Redux state and convert that into a property, mangoes, for my component. So I'm going to implement that now. State to computed. All right, this is just a function. It's taking a state, and this state is going to be a pojo. And I'm going to pick off the piece of it that I want and return an object that's going to map it to the mango's computed property. So I'm using Lodash here to convert the number of mangoes that I have into a range into an iterable. So I'm going to take state.mangoes, num collected mangoes, creating a range so that way down here in my template, I can iterate over it. So each mangoes, however many I have. And then down here at the bottom, I'm going to connect that function, state to computed, to the component. And I'm using connect, which is imported. You can see on line 3. That's imported from Ember Redux. So connect is going to take that function, connect it to that component, and you're going to get the Mango's computed property on that component as a result. And if I jump over here. All right, I typoed something. Okay. Oh. Just trying to be sneaky and all right. All right, so here's half of it. Collecting mangoes, your mangoes, you have no mangoes because we haven't actually caught one yet. All right, fantastic. Okay, so the mango catcher component, which is going to exist right below this, we're going to have two parts of this. We're going to have a state to computed, again, which is going to take the current position of the mango from my state. So it's going to pull that off the JavaScript object, and we're going to assign that to the POSX computed property for my mango catcher element. And I'm also going to define this dispatch to actions function, which is going to take dispatch from Redux, the dispatch function that it provides. And I'm going to map that to a collect mango action. So when that collect mango action fires, I'm going to do two things. I'm going to dispatch collect mango, if you remember that from the reducer. I'm also going to dispatch move mango. That's the thing that generated the random number between 0 and 600 and updates to position X. Oops, no space. Thanks. Okay. All right. This looked better at home. But here I've got a moving mango, and if I click on him, I receive a mango, and he goes flying off the screen. There we go. All right, so you can see this working. So I'm clicking on it, it's dispatching to Redux, it's updating the state. I get my num collected mangoes gets incremented by 1. I get a new random position for my big guy down here, and this just works. So this is kind of neat because you've got this JavaScript object that you can access from anywhere, and it doesn't have to be a component, but you can access it from anywhere. You can be in Ember engines, you can be in some nested engine somewhere, and you can dispatch to Redux, and it'll just work because it's just one overarching JavaScript object, and you can get from it, and you can understand it because it's just a plain old JavaScript object. So that's kind of neat in and of itself. Another cool thing is that because it's so simple, you can get these neat tools that help you development-wise. For instance, you can get Redux DevTools Chrome extension. And if I open this, I can see my current state as it is right now. It's a JavaScript object, and here it is. I've got 9 collected mangoes, and what are the odds that my mango position would be 9 as well? There. All right, now it's 499. So this is cool because I can see what my state is, and if I need to debug something, I can take a look at exactly what's going on. Not only that, but this Chrome extension, which is now too big to see. Let's see if I can dock this somehow. Nope. Well, you can't see it, but this list over here on the left, this list has been tracking the state. Every time I dispatch a new action, this has been tracking that JavaScript object every step of the way. You can't see it on the left, but it's got the name of every action that's been fired. And I can go all the way back to the beginning of time. I can pick a random spot in time, like here, I can click on it, and this tells me that at this point in time, I had 10 mangoes, and my position was 499. If I scroll around, maybe here I had 6 mangoes. Well, I must have reloaded the page. 7. So if I can jump here, I can hit jump, and it'll sort of inject that state into my program. So I can go back here, and I can see that I've got 7 mangoes there. Let me find a different one. So here's one where I've got 6 or 5. Here's one where I've got 5, and I can just jump to this point in time. And I can come back to my application. There it is at that point in time. That exact application state's being reflected there. And this is kind of neat because if I want to debug something or if I want to QA something, I can just be keeping track of my state. If I want to know how I got from A to B when it broke, well, here it is. There's the whole history of my state, and I can click through it and see where did things start to go wrong. So I think that's pretty cool. There's a lot of other neat things that you can do that I don't have time to get into. But I appreciate your attention. And if you want to know more about this, there's an eRedux channel on Slack, on the Ember Slack community. And we're all hanging out there. We love talking about this stuff. You can go to emberredux.com to learn more about installing Ember Redux or using Redux just by itself or some of the other Redux add-ons or Redux utilities that you can use. You can learn more about that on the website, more advanced stuff. And thanks for your time.
Is Ember Redux compatible with pineapples? What tropical fruits does it not work with yet?
Goes well with pineapples. Thank you for your question.
Does anyone have questions for Dustin? Yeah, Hassan.
So if you wanted to save your Redux state on the server, persist it in some way, is there a way to reconcile Ember Redux with Ember Data?
Ember Data and Redux can coexist, to be sure. To be interoperable, I think would be, I haven't seen it attempted. I know people have said that you can use like the Ember Data adapters and serializers with a Redux store if you wanted to attempt something like that. But to use the two of them in their native worlds, like try to integrate them together, I don't think that would turn out too well.
Anyone else?
So what do you do with persistence, for persistence?
Sorry?
What, if you're not using Ember Data, what do you use for persistence?
Me personally? So I'm...
With Ember Redux.
Okay, so Ember Redux is the way I use it, and it can be used in a lot of different ways. It's for your application state. And you can persist that to local storage. You can send that back to your server and persist it that way if that's what you want to do. So there's a lot of ways that you could persist this if you wanted to persist it at all. You don't have to. We're not persisting anything
assuming
here.
you do want to persist it.
Yeah, I guess you could just throw it in local storage. I mean, there's people doing that, I know.
Okay.
Cool. Thank you, Dustin.
All right, thanks, guys.
Okay, cool. We're going to take like a 2-minute break and then jump right into Tom talking about Ember in 2017. Next up, we have Steve Jobs, Tom Dale, who's going to be telling us about Ember in 2017. Tom Dale, everybody.
Thank you, Hugh. Everyone, thank you so much for coming out. It's really great to be here. I'm going to apologize in advance. I'm getting over a combo pneumonia strep throat thing, so if I sound particularly sexy, that's why. And also, if I end up in like a hacking, coughing fit in the middle of this, that's also why. Thank you for the introduction, Hugh. Hugh, I really like the color of your shirt. It's a nice hue. Sorry, I know it's kind of a dad joke, but I like to, hew to the standard. Now, is this the Sanctuary Computer people? You guys work there? So this is the Hue crew? Hue crew. It's going to be like this all night, ladies and gentlemen, so buckle up. All right, Ember 2017, that's what I'm going to talk to you about tonight. Actually, the first thing I want to talk to you guys about is the fact that maybe you heard I just took a job working at LinkedIn, and so that's cool. I don't actually use LinkedIn, so I'm not going to bullshit you. I feel like we work in an industry where people are just like banging down your door trying to give you like six-figure salary jobs. So didn't feel like I was in the target demo. So you might wonder like why would I go work at LinkedIn? Well, the answer to that is that LinkedIn is actually moving their entire front-end experience to use Ember. So both like the mobile website and the desktop LinkedIn.com, when you log in the future, it's going to be an Ember app. We've already started ramping it to what is it? 25%. So 25% of members are like A/B test opted into the new Ember desktop experience. So if you log into LinkedIn.com and you're like, wow, this doesn't look like dog shit anymore, you are on the Ember app. So this is what it looks like. It's like nice, right? It's like Ember. Also, I think I know that guy, and I don't think his name is Patrick. So I think it's like a placeholder image. So that's obviously why they hired me and Robert, who's also here and on the core team. This is like a really big responsibility, and if we blow this, it's going to be very, very bad for Ember. Just to give you some context, LinkedIn has, they have like 400 or 500 million cumulative users, but 106 million monthly visitors. So that's a lot of people every month using this big-ass Ember app. And 60% of the traffic is mobile, and that number is growing. Basically, more and more people are using LinkedIn from some kind of mobile device. So we really need to make this work. We need to make Ember work well. There's a lot of money on the line. Bill Gates, who owns LinkedIn now, is going to be like really upset if we blow this. So I think one thing that's pretty cool about Ember is that we have been around as a framework since 2011, and actually even further back if you count Sprout Core, which was kind of like the genesis of Ember. And the thing, I was looking at like Hacker News today, like old comments from like 2011, and 2011 I remembered was when like Backbone was considered like the cutting edge, awesome way to build web apps in JavaScript, right? And even Backbone was like controversial. People were like, that's a little too much magic, right? Which is, if you think about it, Backbone is like 900 lines of code, right? Like probably many of you write 900 lines of code on a daily basis. And that's how big Backbone is. It's actually not that much abstraction, really. But that was like the pinnacle of what was considered like acceptable in JavaScript. And I think things have changed a lot since then. Angular was really popular, and then React has become very popular, and Meteor was very hot for a while. And I think the thing that's really interesting is that since then, it's like 2011, that's 5-6 years ago now, we've been able to go toe-to-toe with these competitors every round of the framework wars. And that's particularly impressive, I think, because all of the competition other than Backbone had like full-time teams of people working at like big corporations working on it. And Ember was largely a volunteer effort with bursts of activity thanks to some very generous sponsorships from companies that were using Ember and wanted to give back. So I think something really amazing is going to happen this year, which is that at LinkedIn, we actually now have a significant number of engineers who are working full-time on making Ember better. And so I think the history of Ember really is that we've always had these like really cutting-edge ideas, but to be frank, our execution speed sucks. So would have these great ideas, we would talk about them, we'd start spiking them out, but then by the time we actually landed them, one, many of the competitors had already adopted those ideas, so they weren't really that, like, they wouldn't really differentiate us anymore. And more importantly, instead of people being like excited about the new feature, they were just like, oh, finally we get this, instead of being excited that they had it, right? Because they've been hearing about it for so long. So by the time we translated our good ideas into shipping code, our competitors had actually had plenty of time just to adopt the ideas themselves. So one thing I want to say about Ember in 2017, which is kind of like, I hope, is the biggest meta improvement that all of you will notice about Ember this year, is a faster turnaround time between RFCs being published, being written, being merged, and then actually getting implemented. I think you'll notice that we will actually start shipping stuff way faster just because we have this team of really incredible people whose job is to make those things happen. But at the same time, because of our history, we are kind of inheriting this governance structure that has been intentionally designed to ensure that no one company can dominate the framework. And that is something that remains extremely important to me, and I know to everyone on the core team, which is we don't want it to be like the LinkedIn show. We want to keep, there's something really special, I think, about the Ember community, about how many different people from so many different companies, from like one small independent contractor all the way up to the LinkedIns and Tumblrs of the world, being able to use these tools. That's really, really important. And the majority of the project leadership is continuing to remain outside of LinkedIn. We're just going to provide some additional firepower. So I think it kind of gives us the best of both worlds, where I think the Ember team is pretty scrappy. We're used to getting by with like limited resources. Like, I don't know how many of you guys had like the friends who were like raised like really, really rich, and they're like, how much could a banana cost, Michael? $10? You know what I mean? Like, you know, like they just didn't like really appreciate the value of one engineering hour. And I think for Ember, we were kind of like raised with very little resources. So anything we can get, we like really, really appreciate. And I hope we can use those things, we can keep that mentality, we can keep that scrappy ethos, and make sure that we stay very, very focused, right? Very, very focused on building great web apps. I guess I can't promise anything, but I hope that we stay focused on web apps and we don't go off on some expedition to try to help you guys write like iOS apps, for example. I'm not throwing shade. I'm just saying, I think we can do a better job building web apps by focusing on that instead of trying to be like an application development platform or whatever. So, 2017, the focus this year is on mobile. Or maybe another way of putting it is that our focus is on performance, and the performance improvements are going to be the most critical and the most noticeable on mobile devices. And I think it's obvious, there's no doubt that Ember comes from the desktop world originally. And on the desktop, you can get away with a lot more inefficiency. You had bigger processors, you had fatter pipes, generally speaking. And also, I think, you know, if we're being frank, the mobile web was pretty crappy until recently. You know, like the types of apps that many people build with Ember are not something that really would translate to the mobile web. Mobile browsers were limited, buggy, slow, and anyone who had the resources would rather build an Android app or an iOS app. And if there was a mobile experience, I'm sure all of you have witnessed this. If there is a mobile experience, it's kind of like crappy and bare bones, and they would do like everything in their power to be like, please install our app on the App Store, you know? It's like, stop trying to make fetch happen. I'm not installing your fucking app. So I guess maybe to put it another way, it was just pretty darn hard to find a mobile app that we would consider great. And I would guess that most of the people here probably don't want to spend their day building something that's like, oh yeah, that's passable. Like, what do you do all day? Oh, I work on a passable web app, right? Like, it's hard to get up and go to work for too many mornings in a row when that's like what you're building, right? We want to build great web experiences. And the good news is, I think that mobile browsers, mobile hardware, finally, is reaching a level of maturity where we can start building those truly great experiences that are actually, in a lot of important ways, better than native apps. So I've given like a lot of talks about this, about the URL, about this idea that, you know, that you can start using an app instantly just by tapping a link, and you don't have this really painful installation step. I think that's huge. app stores, like trying to prompt someone to go to the app store is going to cause your bounce rate to go sky high. So that's really big. But I think it goes even further than that. This is the coolest thing I saw when I was at Chrome Dev Summit this year or last year, which is this idea that you can associate a Bluetooth LTE beacon with a URL. So if you are at this like restaurant, for example, you just pull out your phone, and the Bluetooth beacon is transmitting this URL, and so you just open up a web app and you get a ticket, right? And you could imagine, and then once you've opened that web app and you've interacted with it, it can send you like push notifications and stuff. Like I think, so you see this like one demo, but you can quickly imagine like 20 different ways this could be cool. Like maybe I could go to the movie theater instead of waiting in line at the kiosk where the touchscreen's broken, I can just pull out my phone and buy tickets. Or maybe I can top up my parking meter with the phone, and the Bluetooth beacon and the parking meter is broadcasting URL. To me, this idea of like the physical web where you can start interacting with the world around you via these apps that you don't have to install is like, to me, that's really, really exciting. And that is starting to kind of really show the strength of this model over something like an app store. And it's way more exciting than Bitcoin, I think, right? So for Ember to stay relevant, we need to not just be okay on mobile. We have to be the best. And so that's where we're going to try to head this year. And I would say there are 3 areas of focus. The first is for helping users that are on a slow network. The second is for helping people who have slow devices, and of course I mean Android devices when I say that. Sorry. And then the third thing is staying jank-free, and I think that affects everyone. How do we build apps that, like native apps, you interact with them and they feel really smooth and the scrolling is really smooth, but then web apps, you know, they can be really jittery when you scroll, and there's the crap like ads popping in all over the place. So how do we help you build apps that stay buttery smooth as you're scrolling? So I'll preface this by giving a warning, which is that I'm going to talk about a lot of our goals and some of our ideas for accomplishing those goals. But of course, everything here is kind of subject to change. We are going to experiment. We're going to collect hard data. And if the data doesn't pan out, if the idea doesn't pan out, then we will discard it. So, you know, please don't hold me to anything that we do here, other than that these are the areas of focus that we're trying to solve. Okay, so the first thing is slow networks. So in order to do anything, we actually have to get bytes to the user. And this one actually impacts me personally a lot because I travel internationally very often, and the T-Mobile free thing is like 2G. It's like, sweet, 128 kilobits. I can definitely check an email with that. That's great. And of course, I ride the subway in New York, which is another situation where you pretty often don't have a great connection. So I'm constantly sitting there waiting for pages to load. So the main thing that you can do with slow networks is, one, of course, reduce the total file size, reduce the total number of bytes you're sending over the wire to get the first experience. And the second thing you can do is you can optimize the asset order. So you can be really smart about what code you send when, to make sure that if at any point that connection gets cut off, you kind of have the minimum viable app on the user's phone at that point. So probably step 1 is something like fastboot or SSR. So this is an example of bustle.com, which is currently deployed and using fastboot. Actually, my fiance wrote this app, which is pretty cool. She's right here if you guys have any questions about this. So this is what happens if you visit bustle.com, which is an Ember app, but the JavaScript doesn't load and the CSS doesn't load. What's pretty cool is I can still get like very critical updates about the news that's happening around the world, such as whether Selena Gomez and The Weeknd, whether them following each other on Instagram is a sign that maybe they're in a relationship. Because like the paparazzi, the paps had like took some photos of them like holding hands. There's a little bit of PDA, but it's like, are they, aren't they? We don't know. He used to date Bella Hadid, who's in obviously Taylor Swift's crew. So like, and if I can't get that information, like that's really bad. I need this really important information. So so this is a good place. Fastboot's in a good place. But I think the next step is we need to focus on performance. We need to focus on the ease of deploying, because right now it's kind of a pain in the ass. I'd really love for there to be like a Heroku for fastboot, and I think actually Heroku is working on this, which is just like deploy your Ember app with fastboot and boom, it just works. And I think also just better debugging, tooling, testing, etc. Right now, running the same app in both Node and the browser, it kind of sucks. And I think we just need better tools, because I think right now a lot of people try out Fastboot and they're like, this is a great idea in theory, but it's just too painful in reality to actually use. We also need streaming responses. Right now, the responses aren't streaming unless they're from a cache. But the point is that this just makes sure that the very first bytes that the user receives on their device are for the content that they want to see. And so as you can see here, even if the CSS and JavaScript doesn't load, people still get what they're after. But of course, server-side rendering, or SSR, is not for everyone. Not everyone wants to or has the ability to run server-side rendering infrastructure. One of the nice things about JavaScript apps, of course, is that you can deploy them statically on S3 or something like that. So for those folks, we just need to get initial file size down so that the people who are on a slow connection at least have a prayer of that JS app payload being able to load. So the first thing is, this is something that Ollie had alluded to in his Broccoli talk, which is RFC 176 was recently merged. And this is something that introduces an ES6 module API for Ember. So instead of having Ember.component or like const curly Ember component equals Ember, or this destructuring API, we instead have this proper module APIs, which everyone's used to using because you've been using this for like 2 years in Ember CLI and Ember AppKit. But now you can actually consume Ember, the framework, using that same module syntax. And so what's nice about this is it will allow us to trim out pieces of the framework that you're not actually using in your app. So this is the tree shaking that Ollie was talking about before. And then something related to that is something that we have been calling Project Svelte, which is why it was kind of annoying when the framework called Svelte came out. They were just copying us. Yeah, well, it's like Michael Bolton, like fuck them. I'm the had it first. He's the one who should change. I actually think Svelte is a cool framework, and it's got some really cool ideas. Our thing is a little bit different. Project Svelte, we've talked about this a long time, but it's actually close to being worked on now. And this is a little bit different from tree shaking, although I think people confuse it sometimes. Basically, the idea is this. Ember, as you probably know, has a very strong commitment to backwards compatibility. And what that means is that if we want to get rid of a feature in the framework, we don't actually remove it. We just put some deprecation notices around it and say, hey, please don't use this. But of course, we still have to ship that code because we don't know if you are going to call like deprecated methods until runtime, right? So we just have to ship it in case you decide to call one of these deprecated methods. And Project Svelte, the idea behind this is that deprecated code is still taking up size, and it's having some cost. So what Svelte will do is say, you as the app developer are going to make a promise to us, the framework authors. You're going to say, I promise that as of version 2.10, I do not have any deprecation warnings in my code. And if you can do that, then what we'll do is say, right, okay, we're going to go through the code base, and all of the code that is for features that have been deprecated as of 2.10 and prior, we're just going to strip that out of the build, right? And so the biggest thing that is blocking this right now is that we need someone to go through and add annotations to all of deprecations in Ember so that we know when they are going to be, or when they were added, right? And the point of this is so that if you say, okay, I promise as of version 2.10, I am not using any deprecated features. But then you upgrade to 2.11, and we've deprecated a bunch of stuff. Well, now we're going to strip it out, and your app is going to break. So the point of Project Svelte is it will strip out all the deprecations from one version, from a particular version past. And then if you have more deprecation warnings, then you just get rid of them, and then you update the thing and say, okay, now as of version 2.11, I don't have any deprecations. And so we can get it even smaller. And I think that, to me, this is a really, really, really fantastic way to remove pressure from us as framework authors to do a major version bump, right? I think if you look around the ecosystem, most libraries and frameworks feel this like really immense pressure to do new versions because then they can like, oh, finally that like API we hate and all that like crufty code we don't like, we can get it out of there. But that breaks apps and that causes rifts in ecosystems. So to me, this is like a really amazing bending of the curve of trade-offs that you normally have to make, where we can remove these deprecated features without having to break all the apps in the ecosystem. So the next thing is something I'll call per route payloads. So right now, when you go visit an Ember app, or really most single-page apps, you deliver the entire payload. You deliver the entire app. So there are ways of dealing with that. So in Webpack, you have things like code splitting, where you say, I'm going to manually manage these entry points and break these up into separate payloads. In Ember, we have engines and the idea of lazy engines, where you manually say, okay, these different pieces I want you to break up into a separate payload. And that's really great. I think that's a great first step. But unfortunately, it requires you as a developer, one, you have to care. Two, you have to kind of go in and do a lot of manual work to figure out how to split up your app. However, we already have a convention in Ember for splitting up your app based on the pages, right? These are called routes. We already organize our application into routes, and as a framework, we already reason about your application as a whole. So we should be able to analyze your app and say, okay, right, when the user comes into this route, /user/123, this is a list of all the components that you could possibly use, and here's a list of the controller, and here's all the services that are needed. And then we should be able to build per route payloads without you having to do any configuration. So when the user comes into a particular route, you just serve them just the minimum set of code needed to render that route. And then when the user's idle, we can kind of stream in the rest of the code for your application. And I think that's really nice, because then you get that much smaller payload just for the piece of the app that they need. And of course, the bigger your app, the more dividends this is going to pay. But you still, because you're streaming in the rest of the app in the background, you still preserve that really snappy, fast, single-page app performance that people really love about JavaScript apps. The next thing is what I'll call #UseThePlatform. So Ember's been around for a long time, and a lot of the features in Ember are things that we felt were needed to improve JavaScript as a language, right? And in particular, the Ember object model, we thought having a class system is a lot nicer, computed properties are nice, observers are nice, and so on. But at the same time, while we were writing these things, we also knew that Ember having its own proprietary system really sucks. Ideally, we don't want to have to do this. And so that's why many, many years ago, Yehuda and others started engaging in the standards process. And so now a lot of the things that we felt were important that we had to roll ourselves in the framework are now actually in the language. And the biggest one, of course, is classes and decorators and things like that. So now that these are starting to become widespread and standardized into the language, we have an opportunity to significantly pare down the code that we're sending as part of the framework if we can instead rely on the features that are built into the language. And of course, that means built into the browser. That's that much less code that we have to ship over the wire. So if we're able to move people to ES6 classes, for example, we can pare down the Ember object model. Instead of being this kind of big thing, it can just instead be this thin layer on top of the classes that are already built into the language. And then the last thing is this idea of code caching. So this doesn't help first-time visitors, but it does really help people who visit on a second or third or fourth time. And the idea here is that we just offer near instantaneous application boots by caching your code in either IndexedDB or the service worker has a cache. We can put code in there. And by being opinionated, I think we can actually do some pretty cool stuff. So let me ask a question. How many people here deploy their Ember app once a day or more? Can you raise your hand if you deploy once a day or more? Okay, so for people who deploy many times per day, or even people who deploy many times per week, you're constantly busting the user's cache, right? A lot of times you'll build these these 500 kilobyte JavaScript apps, but you're like, it's fine because the user it'll be cached. But then if you deploy once a day, well, no, actually it's not cached, right? But if we can move that caching logic and the control over the caching into JavaScript land, into something that we control, we can actually start doing some pretty cool stuff. So for example, we can cache all the modules in your app and then go talk to the server and say, hey, only give me the modules that have changed since the last deploy. And so now we're basically downloading a delta of your app instead of having to refetch the entire thing, even though, of course, in practice, every deploy, most modules haven't changed in your app, probably, right? So that's pretty cool. And then basically what that means is that when the user taps on an icon or clicks a link, boom, they get a very instantaneous app experience because it doesn't even have to touch the network. Okay, so let's talk about slow devices. What do we do for devices where maybe the network connection is good, they're on Wi-Fi, but the CPU performance maybe isn't good, or the JavaScript performance in the browser isn't very good? I remember I was at Chrome Dev Summit, and I was talking to, I forget who it was one of the Chrome engineers. And they were telling me a story about how they were benchmarking Chrome on this Android device compared to like an iPhone 5S or a 5C or something like that. And they're like, we looked at the specs, and we're like, from computationally, these phones really seem like they should be basically neck and neck in terms of performance. But for some reason, the Android phone was doing like way worse, like 50% worse performance, right? And they're like, we couldn't figure it out until we put the Android phone on an ice pack. And then the benchmarks were neck and neck again, right? So you can't just look at the specs, because some of these phones have really terrible thermal performance. And so when the chip starts overheating, of course, it's going to like throttle itself down to prevent itself from like overheating, right? So you can't just look at the specs. You actually have to have well-designed hardware, and sometimes these devices are not well-designed from a thermal perspective. Right, okay, so most people, when they're evaluating framework performance, library performance, or app performance, are looking at render time, right? Like, okay, we're going to put in a timer. Okay, the app's loaded. Okay, put a timer for when we start rendering, do the render, and then calculate the delta when rendering has finished. But we actually have to look at load time. So for example, imagine we have library A and library B. Library A takes 1 second to load and evaluate, and library B takes 500 milliseconds, so half the time of library A. But then it turns out library A, its rendering performance is a lot better, so it's able to render the entire app in 50 milliseconds, even though library B takes 150 milliseconds, right? So the load time is much longer, but if you're only looking at the render time, the actual raw render time to render all the components on the screen, library A is 3 times faster than library B, even though library B, of course, is delivering a much better user experience. The user is actually they're able to interact with it much sooner, right? So I'm sure we can all imagine what the Hacker News headline is for this one. So the point here is just that render time is important, but it's not the whole picture. And we need to start taking parsing and evaluation time much more seriously. So probably some of you have seen this tweet. It's like made the rounds in talks and stuff like that. This is Malte Ubel, who is the project lead on AMP. And he said, on a phone, 1 kilobyte of JavaScript is roughly equal to 1 millisecond of UI thread stall. Size matters. So he's just basically making the argument that every time you increase the size, you are going to increase parse time. And that is technically true, but I think that is very misleading. And the reason it's misleading is that JS parsers are not linear beasts, right? Like, they don't work just by taking one character at a time. Therefore, 1 extra byte is like 1 discrete unit of time increased. In fact, the way that JavaScript parsers work is they have multiple phases, and they have multiple optimizations, and they have multiple heuristics that they can use to try to improve their performance. And most importantly, there's this idea in a JavaScript parser of a lazy parse, or sometimes called a pre-parse, and then something called an eager parse, where it's going to go ahead and try to parse a function right up front with a full parse. So it turns out that in most JavaScript on the web, if you're, for example, like just using jQuery and sprinkling some jQuery on a page, you might bring in jQuery, which is what, like 30, 40K of JavaScript, but you may only be calling a few functions, right? You may never even call the animation functions. So it doesn't make sense for a JavaScript parser to spend all this time parsing and generating bytecode for animation functions that are just never, ever going to be called, right? So every JavaScript parser in the world has something called a pre-parse, or a lazy parse, where it says, like, okay, I see that you have a function here called animate, but instead of actually going through and parsing it, I'm just going to store the code, the raw source code, and then if someone, basically the first time someone calls this function, then I will kind of just in time convert this into a bytecode, right? So that's a great optimization when 90% of the app is never called, and you can just start converting the bytecode that you actually need as soon as it gets called. It's actually a wonderful optimization. Unfortunately, it kind of breaks down in the modern world, where we are all starting to build these bundles of JavaScript that are, they're tree shaken and they're optimized, and actually we're immediately going through and calling all of these functions immediately. And I hope this should be obvious, but doing a pre-parse has some cost, and doing a full parse has some cost. So if you're going to call a function right away, it is much, much better to just do the full parse right then and there, because you don't have to rebuild up the state. You don't have to keep all this temporary state around. If you know you need it, it's better just to do it right then. because a preparse and a full parse together are going to be pretty significantly more expensive than just doing the full parse right then. So maybe some of you saw Nolan's article, which is going around, called The Cost of Small Modules, and you may have seen this project called Optimize.js. And so not to get into the nitty-gritty of it, but Chrome and other browsers know that if you immediately invoke a function, then it is better, you don't need to pre-parse it, just go ahead and parse it. Because if you know you're going to immediately call it, it's cheaper just to do a full parse. And so people are familiar with an IFI, an immediately invoked function expression. You know, you've seen this like parentheses function, and then you immediately invoke the function, right? If it sees that you have a parentheses in front of a function expression, it's like, oh, this is statistically speaking probably an IFI. Let me just do an eager parse right now and just skip the pre-parsing step. So what Optimize.js does is it just like goes through and starts inserting parentheses in your code, right? And actually, like Uglify and most minifiers strip that out because, of course, like that parentheses isn't doing anything. It's just like extra noise. It's increasing your file size. And so all Optimize.js does is it just like goes and sticks parentheses back in, and yet somehow, miraculously, that load time, average load time, is improved by 20%, which is not nothing, right? Like 20% is pretty freaking significant. So I think this just really goes to show you that the way that we think about parsing and evaluation time cannot be distilled down to these very simple equations, these very simple formulas, right? It's not file size. It's, is the parsing eager? Is the parsing lazy? And most importantly, are we doing the right parsing at the right time? So probably many of you have seen, Jeff Atwood wrote an article about like V8 being slow, like JavaScript being slow on Android, and like Ember being really slow. And what had happened is that the way that we packaged up Ember and apps hit pathological cases in V8 specifically. So there were some pathological cases that were not in Firefox or Safari or Edge, but happened to be in Chrome, where V8 was basically, it lazily parsed all of the whole thing, and then immediately went back and eager parsed everything, right? Which is like basically fatal to performance. And so this is one of the reasons that Ember was so slow on Android devices. The good news is, thanks to the hard work of Chris Selden and Stefan Penner, and some really great work, and thanks to an extremely positive collaborative relationship that we have now with the V8 team, we're addressing these issues on both sides. And I think because Ember is able to reason about your app at a very high level, we can start doing some really cool, smart things about knowing, using technologies like Fastboot, where we can actually evaluate and run your app in Node. We can start doing things like, okay, when you come into this route, this is an exact list of all the modules that are actually used. So we can hint to V8, hey, you want to eagerly evaluate all of these, and then we can annotate everything else to make sure that it gets lazily parsed when it downloads in the background, right? So anyway, the point is, once you understand it, it's like the Matrix, right? It's like, once you understand, like, this seems crazy, but then once you start seeing the green dots and stuff, then you see the woman in the red dress, and she's right there, and you can start doing things about it. So that's what we're going to do. We're going to do things about it. And the good news is none of you have to learn about it. We'll just do it, and it'll be great. But now you'll know like something cool is happening. OK, Glimmer 2 templates. How many of you upgraded to the new version of Ember and your template, your file size went down? Can you raise your hand? OK, not a lot of Ember users. Great. So most people who upgrade should see their template size go down by like 20% or more. And the reason for this is that we do something I think is really cool in Glimmer 2. And that is we came up with an entirely new way to represent the templates that make up your Ember app. And this is something that is helping with parsing time and file size. I think it's a very, very compact way of representing dynamic HTML. So let's look at an example of a handlebars template. This is a handlebars template. It's a div with a class, and then we used each helper to loop over the contacts, and then we invoke this hcard component for each contact in there, right? Pretty straightforward, pretty simple. Now, how does this template get compiled down and sent to the user's browser? You guys know? Well, what it looks like is this, something like this. So this is just a JSON structure. It's just an array of numbers and then some extra data that is needed. So in this case, it's like div, which is the tag name, and the class, which is the attribute name. But you can see this is much more compact than the original HTML representation. And those integers that you see, you might be like, what do these numbers represent? Those are actually opcodes. So the way that Glimmer works is it works like a virtual machine. And these are the opcodes that we feed into that virtual machine. So all of those integers map to opcodes that get run by the VM, like open element, create a static attribute, flush the element, which basically means it's just like closed, put a text value there, right? These are the opcodes that this thing maps onto. And you can compare this to something like JSX, which compiles down to these method calls. And actually, this is exactly how the templates in Ember worked in the previous version prior to Glimmer 2. So like Glimmer 1, HTML bars, prior to that, we were compiling down to JavaScript. But in Glimmer 2, we're now compiling down to JSON data structures of opcodes. And that's pretty nice, because parsing a simple JSON data structure is going to be a lot faster and smaller than having to, one, parse JavaScript, which has much more complex syntax rules. And we don't have to invoke methods in order to build this stuff, right? We're just evaluating this simple bytecode. And this is also going to unlock some, Glimmer 2 is going to unlock, on top of just evaluation, download, parsing time, is also going to unlock some really great render performance. So we're working on a new component syntax that's going to remove a lot of the older cruft from the component API. And my hope is it will align better with modern JavaScript VMs to be much, much faster. And internally, we're making more optimizations to take advantage of these VMs. For example, all those opcodes that you see used to be represented as objects internally, but now we represent them as integers. Because, of course, V8 has a fast path for dealing with integers where, like when it compiles it down to JITted code, it's actually just treating these as like, C integers. And my hope is that that architecture where you have this small, low-level VM that's just consuming this bytecode and emitting DOM operations is something that can be optimized and written in a language that compiles down to like Asm.js and WebAssembly. So we're actually running this, it's like a true VM and running at a very, very low level, which I think hopefully should be quite fast. Okay, so let's talk about runtime performance and de-janking your apps. So jank is maybe a term you're familiar with, but the idea just means that your app lags when the user tries to respond to it. Someone like taps on something, they scroll, and instead of it responding immediately, it kind of sits there and pauses and thinks for a little bit. And that feels bad, right? Like that's one of the things that people really love about native apps is that you can take that view and you can flick your finger and it's going to keep scrolling and it's buttery smooth, to use a Steve Jobsism. So how do you de-jank? Well, there's a magic number, 16.67 milliseconds. And what you may realize is that this is 1/60th of a minute, right? So, or sorry, a second, 1/60th of a second. So if you want to get 60 frames per second, that means that every frame has to be evaluated in 16.67 milliseconds or less. And that's not a lot of time. 16 milliseconds is not a lot of time. So we need to help give tools to developers so that, one, they realize when they're writing code that takes longer than 16.67 milliseconds, because it's real easy to do. And two, we need to make sure that all the framework code is keeping in line with this budget, this time budget that you have when you're writing a 60 frames per second app. So I think a big question is the framework slow or is my app slow? And of course, if we don't give you tools to identify where in your app it's slow, the default is to assume the framework is slow, right? And that's fine. We should be giving you these tools. So one thing that we're going to be working on this year is providing additional instrumentation to help you understand the runtime performance of your app. And in particular, to make it clear where the boundary between framework and app code is. So here's an example. This isn't maybe like a really great example, but I messaged Rob like 20 minutes before we came over here saying, do you have a screenshot of that thing you're working on? And this is the one. So the idea here is, does anyone recognize this? Does anyone know where this screenshot's from? See, timeline, yes. So this is from the developer tools in Chrome, which is like the flame view, people call this, right? So this is a profile of an application, and it's telling you where the JavaScript runtime was spending all of its time, right? So each block is like a method or something. And we have a library called Heimdall that Steph Penner and David Hamilton, I think primarily, are the ones who've been working on it. And Runspired, Chris Thoburn. So this is a library that does instrumentation, but is designed very specifically to be as low impact as possible. So the idea is that you can leave more instrumentation on in your application in production or in development, and this instrumentation should be as cheap as possible. So we can measure exactly where in the framework, like how many times does your component method get called? And we can take that information and we can actually augment the built-in Chrome developer tools to give you more meaningful information. So instead of seeing this stack that's like deep in the framework internals, and people treat it like it may as well be like a Linux kernel segfault for all they know, right? Like it's like once you get above like 3 frames, people are like, no, fuck this, I'm out. We can put these annotations so it's really obvious, like, oh, instead of this is like slow because of Ember, oh, this is slow because I did something slow in my did insert element hook, right? And also because the framework is the one calling into your application code, we're calling into like did insert element, we're calling into the routes model hook. We can measure how long each of those things takes, and we can do a much better job of saying like, yo, we all together now, we all had 16 milliseconds, but you motherfucker in did insert element decided to do something that reflowed the entire DOM, and you just spent 100 milliseconds, and that's not okay, So we can tell you that. But then, of course, the big question is like, well, okay, so I'm writing this thing, and it's like really slow, but JavaScript is not multi-threaded, right? You only have this like one single thread of execution. So what do? Well, I think the answer to this is that we need to support. This is very controversial, and probably people on the core team will be upset but you'll be happy that I said this. I think we probably need support for first-class generators everywhere we have hooks where we call into your application code. So if you're not familiar with generators, they're a pretty new feature in JavaScript. But if you've used like Python and stuff, you may be familiar with these. So the idea of a generator is it's just a function, and anytime you have async code, you have this yield keyword, and the yield keyword basically pauses the function, but it keeps all the state on it. And then in the future, something else can call back in, and it resumes exactly where it took off. Where it paused, I should say. So the nice thing about generators is that we can say, hey, this is taking a long time. And so you can kind of just like liberally sprinkle yields into that function until it starts taking below that 16 milliseconds, right? This gives you a chance to break up long-running work in a way that lets you yield back to the framework and thus yield back to the browser so it can scroll and it can paint and do all those things. And then we have a way of getting back to where you were before. So you can keep doing the expensive work. Now, the astute observer may be thinking right now, okay, well, this is cool, but obviously, like, generator syntax sucks. Like, what is this, like, stars? Like, that's weird. That's not good. And I've heard about async functions, which return promises, and that seems like way better. So why not just use async functions? I hear you thinking. The answer is that promises are not cancelable. So, for example, if you have a component that's doing some, like, long-running work, and then you transition to a different page, we need to tear down that component, and probably you nor the user want to sit around waiting for that component to finish this long-running task when this component's not even on the screen anymore, right? And if it's a promise, then once that promise and that async function gets kicked off, we as a framework have no way to cancel it. And the nice thing about a generator is that we're the one calling into it. Every time you yield, haha, you're giving us the power back, right? And so it's up to us to decide when we call back into you. So if this component goes off the screen, we just stop calling the generator, and no more expensive work is going to happen. OK, so the last thing here is pause and resuming the Glimmer VM. So we've already talked a little bit about this idea that the Glimmer VM is this very low-level thing. It compiles your templates, your handlebars templates, into these opcodes. These opcodes get fed into the VM, and the VM translates those opcodes as it goes into these operations on the DOM, right? Pretty cool. And what's really cool about it is this is kind of this like linear set of opcodes that we're just churning through one by one. And what's cool about that, because it's linearized, it's not a recursive algorithm, right? You're just kind of chewing through this array in order. What that means is if we detect, oh shoot, we're getting close to that 16 millisecond budget, we can just pause, right? Because we just have a pointer into this array of opcodes. So all I do is say, whoa, let's stop, let's give control back to the browser, let it paint, let it update, let it scroll, let it respond to the user events, whatever it is the browser needs to do to not be janky. And then we'll say, but as soon as you're done with that, as soon as you're done updating, please call me back again because I still have work to do. And then at that point, we still have this pointer into the opcodes, and so we just keep playing through those opcodes exactly where we picked off. right? So this is kind of, I think this is like kind of a theme, but really the best of both worlds, where we get control over DOM rendering. We get to keep everything on the single thread. We don't have to move your whole app back into like a web worker or something like that. But at the same time, we are able to insert ourselves in, notice when that budget is about to be blown, and make sure that we give the browser an opportunity to do the right thing. So I'm really excited about that. And actually, this is an idea that's not, it's not just in Ember. It's the React Fiber, if anyone has been following the React Fiber effort, is a very similar thing. The idea that you can pause and resume this like rendering context. Okay, so in summary, I just want to point something out which I think is really interesting, which is that historically, Ember has been like the big monolithic framework, right? It's always like Ember's, like if there's a spectrum of complexity, it's always like Ember like way over here, this like big thing that it's good if you're like the Twitches and the LinkedIns and the Tumblrs of the world for big teams. But most people don't really need all that complexity, so you'll pick something over here in the middle. And I think what's really interesting is that for the first time in a round of the framework wars, was this like round 4, round 5? What are we in right now? Just like delirious from framework wars. For the first time, Ember is no longer the big monolithic framework. In fact, I was reading an article about Angular 2 yesterday, and it was like its critique of Ember was that it doesn't help you build like iOS apps, right? And I was like, well, like I consider that a strength. So for the first time, we are the ones who are actually like right in the middle. So we're simpler than Angular 2, which tries to be everything you need for web development and native development and just like everything. But we also offer a more complete experience than React, right? Like I think React is really fabulous. I mean, I think it's pretty obvious we lifted a bunch of the ideas in React like directly and put them into Ember. But when people love React, but when they try to scale it up to bigger teams, bigger apps, that's where there's not really a clear story. And so everyone has to start reinventing the wheel. And I think if we're being honest, JavaScript fatigue really is just shorthand for React fatigue. And and so I'm really excited about this year because I think the nice thing about 2017 is that as a community, I don't actually think we're trying to build upwards anymore. Like I remember in the very beginning, we were like, we got to build Ember data, and we got to build Ember CLI, and we got to build like documentation, and we got to have like a component library, like all this stuff, right? We knew we needed all that stuff. But what's really amazing is that finally we actually have all of it. And so we're not really trying to build upwards anymore. I think we found the shape of the solution that we're happy with. And we believe that we have this set of fantastic tools that cover the majority of what you need to build a modern progressive web app. And so for me, 2017 is all about focusing on performance, refining the developer experience, almost like our Snow Leopard release. You guys remember Snow Leopard? That was like the best OS 10. No new features, just polish and infrastructure and stability. And I hope that's what 2017 will be for us. And I am very, very excited to work on all of these things with all of you this year. So thank you very much.
Thank you, Tom. Has anyone got any questions for Tom Dale? Anybody? Yeah. One sec.
Hi. Thanks first for the talk. You talked about using generators to pause execution. Is that like similar to like Ember concurrency, like the? Ember.
Hot mic. Hot mic. Oh. Yes. So Ember concurrency is built on top of generators with some really nice abstractions around things that are task-oriented on top. So coordinating multiple tasks. I mean, Makti is obviously the better person to speak to this, but coordinating multiple tasks, making sure things run either concurrently, sequentially, et cetera, being able to query the state of that task. So I think we're talking about something maybe, I think they're complementary, in other words.
Cool. So you wouldn't like merge that into core or anything. Like,
Whoa.
okay. That's
Well.
controversial.
Let's not get crazy.
Okay.
here. I actually really like Ember concurrency, and I have used it, and I would not certainly be opposed to it on principle.
Okay. Thank you.
I just had a question about a lot of the stuff that you were talking about. I think has parallels with a conversation around progressive web apps, and some of it probably doesn't. And I probably don't know what some of those differences are, just at the level of the stuff that you were talking about. What do you see similar or different as far as the direction that Ember goes in, as it pertains to, the PWA conversation?
Great question. I think PWA is a pretty vague term in a lot of ways, right? So if you, so Google are the ones who invented this term, and if you go onto the website for PWAs, it's like, what is a PWA? It's fast. Okay, great. Like that is one of the 3 requirements for being a PWA. But I think generally speaking, when people talk about PWA, typically what that means is it has a service worker, right? Like I think service worker is kind of like the shorthand for whether something is considered a PWA or not. And I think I am really excited about PWA. I'm really excited about Service Worker. I'm really excited about the stuff that the Chrome team has been doing on Android to make these web applications a first-class Android experience, right? So for example, one of the most annoying things about web apps on Android is that they don't participate in the task switcher. So if you're switching between apps, your web apps aren't going to show up. You have to go to Chrome and then go to the Chrome switcher, right? That's changing. So they're actually going to make PWAs interact as a first-class citizen. It's going to be indistinguishable as an app for the average user. And in fact, they're changing the verbiage, I guess, so part of the progressive in PWA is the idea that it starts as a website and eventually becomes like a native app, right? So if Chrome detects, hey, you're visiting this app, this web app multiple times, it's going to start prompting the user like, hey, do you want to add this to your home screen? But I guess they did research and no real user actually knows what add to home screen means. So they're just changing it to say install app, which I think is great, right? This is becoming a full-blown app. And I think it would be very foolish of us to not take advantage of that. And I actually think one of the strengths of Ember is it says, hey, we're not trying to hide the fact that building a client-side application is complex, right? It's really, really hard. And I think a lot of the heartache involved with people building JavaScript apps is they don't really take the client-side architecture seriously, and they're like, oh, this can't be really any different from writing a Rails or a PHP app, right? But of course, it's way harder, because you're now building a distributed system. And I think Service Worker adds even more complexity on top. And I just feel pretty intuitively that there's going to get to a point where the table stakes for writing what's considered a great web app, a great PWA, is going to be so high, right? It's going to have to sync data offline. It's going to have to sync data in the background. It's going to have to save itself to the cache. It's going to have a icon on the home screen. It's going to have to load instantaneously. It's going to have push notifications. There's all this stuff that an app is going to have to do just as table stakes. And I think there's just a point where hand rolling that for every app is just going to become too hard for most people to do. It's too hard for me to do, right? And I've had a lot of experience doing this. And so for me, that's why solutions like Ember or things like it become even more important, because I think we can bake a really great PWA experience into Ember out of the box. And it's certainly my hope that when you start a new Ember app, we can give you a default service worker that has some good defaults that make it perform well, and it's configurable, so however you deploy your app, it works and downloads these assets and everything. So I'm all on board the PWA hype train. Choo-choo! I'm on board. And that's one thing I would love to focus on this year as well. We have less of a concrete plan, and I was told not to hype too much. This is actually a pretty short-range projection, right? I actually don't think this is all of 2017. I think it's maybe first quarter, first half, but I think there's going to be some even cooler stuff coming, Remember, we don't give timelines, though. Yeah, we don't give timelines, because Robert's the one who does the work. Sorry, that was rambling. I don't know if that answered the question.
No, that was great. Thank you.
How is a PWA different to a PDA? Or
Are you referring to the Palm Pilot or like a makeout sesh?
Public display of affection, actually.
So I found what you said about the physical internet really interesting, removing all the barriers as almost a form of augmented reality. So my question is it your job or your team's job to sort of market those apps as something that should be created, like, sort of push forward the possibilities, or are you guys just sort of making the tools and people can make whatever they want?
That's a good question. I don't really know the answer to that because I've only been there for a few weeks. Okay. But my hope, one thing I really appreciate about LinkedIn, actually, and one of the reasons I felt comfortable going to work at a big company is that their attitude towards open source has been really fantastic. So I am free to come speak at events like this, to go talk to the other browser vendors, to work on open source, and really I don't feel constrained at all. Like I feel like just as much of an open source citizen as when I was working at a very small startup with like 5 people. Right. So yeah, I hope that part of our role is to explore what makes web apps great and to try to champion that in the greater world. Like, I love being an ally of Google when they're pushing really cool stuff, or any browser vendor, really. So yeah, I certainly hope so.
Thanks.
Does anyone else have questions? Yeah.
Yeah, I was wondering if you could elaborate a little bit more on the scalability issues of React and how Ember solves them.
Sure. So first, let me just say that I think any tool that solves the job is a great tool. I'm actually not like dogmatic. I don't think there's anything wrong with React, right? I just think sometimes there are things that can be improved upon, which is not to say something is bad. So to me, do you bowl? You're a bowler?
Oh, no, I'm not a bowler.
Okay.
I'm not a bowler.
Me either. And so when I go bowling, I embarrass myself, right? And so what's the first thing that you and I do when we go to the bowling alley? We ask them to inflate the bumpers, right?
Okay.
Okay, Ember is the bumpers. You see what I'm saying? Okay, because you got a lot of people working on this team, right? Especially bigger organizations. You have a lot of people working on a team. Many of them are junior developers. Maybe they haven't been programming for very long. Maybe some of them have been programming for a little bit longer, but they haven't been doing like web applications. They haven't been doing JavaScript. And keeping everyone on the same page is actually pretty tough when it comes to how do we lay out the file structure, what's our code style, how do we architect this thing, right? And it's not to say that you can't enforce those things without a more opinionated tool. Of course you can, right? You can do code reviews, you can whack people over the head with like a Nerf hammer. There's like strategies for dealing with it. But my belief is that encoding the norms of your team, the social norms, the technical norms, as much as possible into software, into the code, is much more scalable, and it's going to lead to a more cohesive result, right? Because at the end of the day, you have deadlines, you're tired, you just don't have the energy to nitpick that code review that does something slightly wrong, right? And it's a little bit more than that, which is that, to me, having the bulk of the community share those things is just as important as having the team share them, right? Because it means that if that junior developer looks up something on Stack Overflow, or they go read the documentation, the information they're getting is hopefully going to align with the team, because the team aligns with the code, and those opinions are all encoded in the code. And also, it makes it easier for us as framework authors when we have the whole community on the same set of opinions. As things change, to me, this is like the reason Ember is still a thing in 2016, even though there are very few backbone apps in 2011 that are still modernized, right? And to me, the reason is those strong set of conventions and opinions baked into the software, shared by the team, and more importantly, shared by the wider community and the documentation and the tools and everything, let us keep the community moving. And again, it's not to say you can't reconstruct that, but even though Ember is far less popular than React by itself, I wouldn't argue that. I would argue that the set of people on the same set of Ember conventions is much larger than any one particular permutation of React, Redux, React Redux, React Router, Reflux, GraphQL, Relay, Babel, etc.
Right. Okay. But really quickly though, like if there's like opinionated app structures out there for like React and Redux app, like how does Ember compare to that? Because for instance, like there's like Ember Redux,
yes,
and which doesn't play well with Ember Data Store, and so like, I mean, I see that as like Ember hasn't really figured out which way they want to go in terms of managing state.
So I think the fact that Ember Redux and Ember Data maybe don't integrate together well has more to do with the fact that Redux is designed for application state, which is kind of an inherently transient thing, even though of course you can persist it. And Ember Data, which is designed specifically for persisted data that's like talking to an API server, right? Like Redux is not really designed to talk to an API server. It's designed to track, is this disclosure triangle open or not? Is this tab, which of these tabs is selected, right? So if they're not compatible, it has more to do with the fact that they're trying to solve different problems, I think. But what I will say is that I think the existence of Ember Redux, I think proves the point, right? Because as you saw in Dustin's presentation, the Redux bits plugged into Ember's conventional structure, right? So we have routes, and actually the style presentation as well. We have components, we have routes, we have services. These are like very well-defined architectural pieces. And so actually having that shared understanding means that you can write an Ember Redux add-on, and as the author, you know exactly where to slot it in. And it also means that as the framework authors, we're like much less likely to break it. Yeah, I mean, like Redux is, I just don't think that opinionated. Like if anything, I would say Relay more. I actually think Relay is pretty cool. I think there's some cool ideas in Relay, but I don't think any of these things give you any opinions about, like, for example, how you lay out the file system, the naming conventions, how all the stuff gets looked up. It's all just like importing a module, right? And so all of those conventions about where things live are up to you. And maybe it seems trivial, and sometimes it just boils down to taste, you know?
Thank you.
Yeah, thank you.
So with Ember focusing on, I guess, PWAs and web apps, that would tell me that you're in a comfortable place with device APIs. So are device APIs something that you see kind of merging towards a standard between generally Android and iOS? And if not, is that something you would have kind of abstracted in Ember at all?
When you say device API, you're referring to like media capture and like location, or
getting photos, contacts, push notifications, stuff like that.
Got it. You know, for me, I don't think Ember as a project has any desire to create abstractions on top of that. You know, it's such a different world now than it was in 2011, because in 2011, there was no package manager to speak of. You know, NPM was very new, and it was only for Node, and Bower didn't exist. I mean, in that sense, the world was a better place. But now, in 2016, we have NPM, which is fantastic. We have Ember CLI. We have this really great add-on ecosystem. So I think that keeping core small and light and focused, and just setting the level, like the bare minimum of opinions needed for the community to build on top of, is where it's at. And so, you know, if you find that cross-device APIs need normalization, if we need like a jQuery for photo capture, for example, I really hope that you're the one who can write an add-on and make it really popular. I think if there's one thing that I really love about the Ember community, it's how much it values quality and shared conventions. And I don't know if people have been on this website, but there's a website called Ember Observer. Have you guys been on that? Yeah, it's pretty fantastic. So Ember Observer is a website that tries to curate the best add-ons in the Ember ecosystem, and they all have ratings based on like test coverage and how popular they are and how well maintained they are and so on. It would be fantastic if you could write an add-on, and then I think what you'll find is that if it's a high-quality add-on, it's well-tested and well-maintained, then the whole community will just rally around that, and you won't find yourself with like 1,000 different competitors. So please feel free.
Cool, thanks.
Yeah. Maybe you guys.
So 2 questions. Number 1, how do we get Ember to be considered more of a, I want to say first-class citizen, but I don't mean it kind of like that. I mean, in the way that you touched on earlier, there's the new hot framework on Hacker News, there's the React crew that they have a very big voice. And Ember has historically been this big monolith. How do we change that idea throughout the community and get people to make Ember more approachable for the beginner? And that, I guess that goes from everything from like blog posts to Stack Overflow, et cetera, et cetera. And how do we make it more accessible to those who are more advanced in those other areas? So the more advanced React developers, the ones that are looking at jQuery, how do we make Ember appeal to them when it's currently considered the big monolith?
So that's a great question, Ali. Thank you. I think, I think people in a lot of situations were right not to use Ember, right? Because I think there's kind of this spectrum of complexity, and you have to guess where on the spectrum you are before you start, right? Because you have to guess the technology that you have to pick the technology before you build the app, right? You kind of have this chicken and egg problem. So you have to guess the level of complexity. And the beauty of a small, flexible library like Backbone or React or anything like that is that if you guess wrong, if you guess too little complexity and you have to go up, well, you can do that, right? Like you can layer stuff on top of React, or you can layer stuff up on top of Backbone. And the reverse is not true with Ember, right? Like if you guess wrong, like actually I didn't have this much complexity, then paring that down is non-trivial. Right? People just abandon and use something else. And so I think that's why you see like Ember, in terms of like total raw number of users, is not as popular, even close to it, as something like React, and certainly not Angular, but at the same time you still have like these really big important apps using it, right? So like how do you explain that? And I think the explanation is, for those people, like they obviously have the problems that Ember's trying to solve, so it's a good fit. So the question is like, how do you change that? And I think what we are going to start doing this year is actually breaking the framework apart into individual modules, right? Because there is, it is annoying when the framework is paternalistic. And yeah, like I think the opinions of Ember are good, obviously, right? Like many of them are my opinions, frankly. But when the opinions are not what you want, there's nothing more frustrating than having to fight the framework. And I get that. I've experienced it. So I think rethinking everything that we have in terms of the primitives, like the low-level pieces, and making it easy to use the pieces of Ember with whatever you want, right? So we still have a cohesive story. We still have a full set of documentation. We still have a glide path from small thing to more complex thing. But I think the fact that we have Ember Redux talks is like really fantastic. I think that shows that we are getting out of this kind of closed mindset of the Ember community, like we're kind of off our own tribe doing our own thing. I would love to see the Ember community like really be just another part of the JavaScript community. And I would love if we could pull out the Ember router and you could use the Ember router with your React app, Or I would really love it if we could make Ember Data not have a dependency on Ember. So you could use Ember Data in your Angular 2 app because you're going to need it. You know what I mean? So I think if we do that, I think we've nailed it, right? Like I think for a certain category of app, I actually do think we've nailed it. And I think the proof's in the pudding. So now the question is, how do we kind of take that, the good stuff, and simplify it and make it more accessible? And hopefully, like a lot of the stuff I think is like part of the answer, but I'm trying to figure out, you know, what I can say before it's ready. But I think we will have some really exciting stuff at EmberConf that will address this exact question.
Anyone else? I think we'll do one more.
Got a gentleman over here.
Whereabouts? Oh, coming to you. Hi, Jay.
Thank you. Thanks for your talk. It's great stuff. My question is about the splitting up idea. So when you have these smaller components that make up the whole that you can use independently, for example, you have a router or maybe Glimmer, how would you differentiate yourself? What do you think in the marketplace, right, from other libraries that are kind of doing the same thing, right? Because Ember's core value seems to have been like, it's all there for you.
Yes.
Right? You've got your opinions. You don't have to think about bike shedding too much. You can just build your app, and you go to another Ember app. You kind of know how the lay of the land. Once you break it up, what's your unique value that you're offering for these individual libraries?
Right. So I think it doesn't change, right? So having a one-stop shop where you have documentation that says, hey, you're new to web development. So we're going to walk you through, you know, creating a new app, creating a set of components, telling you how client-side routing works, having one cohesive narrative. I think that in and itself has value, but also all of these defaults are going to stay the same, right? Like when you initialize a new Ember app, you're going to get the same stuff. It's just that now you have the ability to delete it if you don't want it, right? Like I think that's the key difference. So in some sense, it's more about how we talk about it, the story we tell. It's not a story of like, hey, here's 1,000 modules, go ahead and grab whatever you need, right? I don't think that's compelling. I don't think that's what we want to do. I think what we want to do is say, here is what we believe are the correct set of defaults for building a web app. But if you happen to disagree on a couple of these, then that's no problem. It doesn't mean you should not use Ember. It means you can swap out, you know, our state management thing for Redux or whatever it is. So I don't think it fundamentally changes. I think defaults are way more powerful than people give them credit for. Have you seen? Did you see that study about organ donation? Have you seen that? About organ donation, like on driver's licenses. Have you seen that? Right? It's like some countries the organ donation rate is like 95%. In other countries it's like 60%. Right? Like when you die on your driver's license, it's like, may we harvest your organs to save someone else's life. Right? And so if you look at it, it's like all like 95%, and then it's all like 60, 70, 40%. So like, what's the difference between these countries? And it turns out the difference is that the countries with like 95% opt-in, or the 95% like, yes, you can take my organs, the check mark on the driver's license form is I have to opt out, right? But the other ones is I have to opt in. So you would think like something as grisly as what happens to my organs when I die is something people would take seriously, and yet even something as dramatic as that is dictated by whether I have to go through the extra 0.2 seconds of effort to check, right? And I think that's true of frameworks too, right? Most people are not going to opt out, and that creates the cohesiveness that I was talking about earlier. Cool.
Thanks, everyone. Thanks, Tom.
Thank you.
Ollie's going to look up a bar for after this, so give us a sec. Yeah.
So thank you everybody for coming. Obviously this is Tumblr. I work at Tumblr. We are hiring. If anybody is interested in having a job here, come and talk to me or my colleague Matt. We'd love to talk to you. We do some stuff in Ember. It's kind of like under the radar right now, but hopefully next month at Ember NYC I'll get to talk to you about it. So please come back then. And thanks for coming. And please take any leftover. Oh, it's gone. The pizza's gone. Thanks very much.